The algorithm that I will be going over today is bucket sort. So what is bucket sort? Bucket sort starts by taking your data set and then partitioning it into different buckets or groups representing the data range. For example, for the data set containing decimals between 0 and 1, we would look for maybe 4 or 5 buckets dividing up the range from 0 to 1. From then on, within the buckets, the individual data or elements in those buckets are then sorted using any other sorting method, such as insertion sort or selection sort. Then the data is regathered in an ordered manner, either from smallest to largest or largest to smallest, depending on what you're trying to do. Bucket sort is a non-comparison based sorting algorithm. It is stable if the within bucket sorting method is also stable, and it is not in place because it uses or creates extra arrays that requires memory to build the buckets. Here's a visual representation of what bucket sort does. You can see at the top there's an array or a data set of 10 numbers, integers. Below is a visual representation of how we might divide up the array into 5 buckets, in this case in sizes of 5, 0 to 5, all the way up to 20 to 25. And then you would just go down the list of the data set and place each of these integers into their respective buckets. As you can see, 10, 1, 24, 7, 18, 16, 13, 23, 8, and 15. Here, within each of the buckets, you would go through and then sort the elements within the bucket. So in this case, 1 would get sorted, the bucket from 5 to 10 would get sorted, which would be 7, 8, and 10, and you get the resulting buckets and integer orders. From here, you can just go from left to right, top to bottom, to get your outputted sorted array. Bucket sort has a pretty strange time analysis depending on how things are set up, but in general, you have to put each of the n elements into one of the k buckets, which requires O of n time. You then have to go through each of the k buckets and sort the elements. Depending on your sorting algorithm and the amount of elements, the process of actually sorting each of the buckets does take some time, but we have to assume here that there are enough buckets to have few enough elements in each of the buckets that the sorting time required for each bucket is negligible, or basically O of 1. For example, if there are enough buckets, each bucket may have a max of maybe 2 elements, and then even sorting methods such as selection sort would be able to do them in negligible amounts of time. Therefore, the time complexity of bucket sort the average time complexity of bucket sort is O of n plus k. The worst case time complexity is O of n squared, which happens when all the elements fall into the same bucket. And this is due to non-uniformly distributed data sets. Some of the pros and cons of bucket sorts. Pros: it does reduce the number of comparisons, similar to other sorting algorithms such as radix sort, which makes it really good for larger data sets. As you can see in the time complexity, which is O of n plus k. So there are a good amount of cons for bucket sort. One is that it cannot be applied to all data types because you have to easily be able to map data into certain buckets while maintaining the order of the data. So it's really good. It works well for integers and strings, but doesn't really work well for other data types. The efficiency does drop, as we mentioned before, when there's a lot of clustered or non-uniformly distributed data within the set. This causes some buckets to have a lot of elements in them, which makes it so that the sorting of those buckets becomes not negligible in terms of time. As you can see, the worst case time complexity when basically all of your data falls into one bucket is O of n squared. Some more cons of bucket sort. It does require that you know the bounds of your data set in order to create the buckets. For example, if you were to make buckets dividing up the range from 0 to 1, and just assuming that none of the numbers fall outside of 0 to 1, if you were to get data that fell outside of that, it would not be included in your sort, and you actually lose data using BucketSort. In many cases, when you use BucketSort, it's also advantageous to use another specialized sorting algorithm, such as the professor's favorite radix sort or counting sort. And then lastly, BucketSort also may require some tuning of the number of buckets to get optimal performance, as you have to balance between how many buckets you want to use to get a small enough amount of elements in each bucket versus how much memory you want to use to allocate to creating those buckets. A quick summary of BucketSort: it's a non-comparison sorting algorithm similar to radix sort, which places elements into buckets based on their values and then sorting the buckets. It can be really fast with a time complexity of O of n plus 1 or O of n plus k, and it's good for sorting large data sets. However, it's not great for sorting non-uniformly distributed data, and you also need to know the bounds of your data, which may limit the use cases of this sorting algorithm in the future.